Hey guys, so today we'll be going through a DHCP relay, and it would just be a client gaining an IP address from a DHCP relay process. So the MX will be relaying over to another DHCP server, and we'll take a look at the packet captures and identify how the DHCP relay packets work. I hope you enjoy it. So here is our basic setup, and you have PC1 and it doesn't have an IP address at the moment. What it's going to be doing, it's going to be requesting an IP address in the sales VLAN, so it will send DHCP packets over to the MX, but the MX will not be servicing the DHCP packets for the sales VLAN. It will relay them over to the server, the DHCP server over here, which is 192.168.50.9, and the server will get back to the MX with those responses, and the MX will relay this back to PC1. So let's go ahead and go over to dashboard and take a look at my configuration. So here is dashboard. So here you have VLAN 50 and you have my VLAN 101. So VLAN 50, as you can see, is running a DHCP server, so the MX will give IP addresses to clients for VLAN 50. For VLAN 101, however, it's going to relay over to a 192.168.50.9. Now let's go through a bit of a prerequisites before you can configure a DHCP relay. So if you go under the security and SD-WAN address and VLANs, you must have VLANs enabled in order to relay to another DHCP. So you can't have a single LAN. You need to be running VLANs. The DHCP server configured must be in a subnet, configured on the MX. So for example, this DHCP server, which is 192.168.50.9, is in this VLAN, so that's fine. Servers sitting behind a non-Meraki VPN peer are not supported. You can't relay over to a non-Meraki VPN DHCP server. If multiple servers are also configured, the DHCP relay packets are sent to both servers. So you can add another server over here, and you can specify, let's say, .10, and the DHCP relay packets will go to both the DHCP servers, but whoever gets back to the DHCP requests will be that relay for that instance. If DHCP relay is configured behind, let's say, a default route from, let's say, a hub MX, the hub MX must still advertise the subnet where the DHCP relay is sitting in. So it must do that explicitly. So if it's a default route, so let's take a look and explain that in a bit more detail. So if we go over to the route table of this MX, or let's look at the configuration page. So here you have a hub. So this is Lander branch. Its hub is configured to be the Lander HQ appliance, and it's got a default route configured. If we then go over to the route table, and you should see the route, which is this 0.0.0.0. It's a Lander HQ appliance and Meraki VPN. So it's a Meraki auto VPN route. So let's go ahead and take a look at also the VPN configuration page for the Lander HQ. So here at the moment, although I have a default route on the branch to forward all my traffic, like auto VPN traffic, over to the Lander HQ, if I had a DHCP relay in this subnet, let's say it was 172.16.100.9, if I had this disabled, the DHCP relay service wouldn't work. I need to have this enabled. Even though there's a default route in the route table, the HQ still needs to advertise the subnet where the DHCP relay server is sitting in. So those are the kind of the prerequisites. And also one more is that, just to note down, is in this example, the sales VLAN, the client will be sending a DHCP packet, a discover packet, in this VLAN. So the MX will use this IP address, the SVI IP address, where the discover packet is seen, to relay over to the DHCP server. So essentially, we'll see that in the packet captures once we test. So let's go ahead and go over to my client machine, and let's configure it to get a DHCP IP address. So here we are is the workstation, so it's PC1. So let's run ipconfig on this PC, and at the moment it doesn't have an IP address. So what we're going to do is we're going to configure ipconfig renew. So let's force it to get an IP address by doing an ipconfig renew. But before I do that, what I'm going to do is I'm going to take a packet capture. So let's head over back to dashboard to start a packet capture. So here I've gone to network wide and packet capture, and I have the security appliance that I'm taking a packet capture on, and there's the LAN interface. I'm running it for 120 seconds. So let's begin this capture and let's head over back to the workstation. So here we kind of come back to the workstation and let's just run that ipconfig renew. So that's run, and now we have an IP address of 192.168.101.3. So let's go ahead and take a look at the packet captures and see what happened. So here is our packet capture, and I've used the filter bootp to filter out the DHCP packets. So let's go ahead and take a look. So you have the first packet. So it's sent via Alpha Alpha Charlie 11, which is our PC1. So that just sends a discover to the MX, and it's a broadcast message. I notice it's on VLAN 101 and it wants an IP address. It's actually requested an IP address of 192.168.101.3 because it's probably had that IP address before. So let's click over to the next packet. Now this is the MX. So the F89E is the MX, and this Alpha Alpha 5501, as you can see, is our server. So now the discover packet is going over to our DHCP server, and then what happens is our DHCP server then gets back with an offer. So let's take a look at the offer. So here you have a client IP address being offered, 192.168.101.3, and then you have the next server, which is the DHCP server's IP address, and then you have the relay agent IP address, which is the IP address of the MX. And notice the IP address that's being used for this via the MX is 192.168.101.1. That is because the first discover message was sent with the VLAN ID of 101 by the client. So essentially that offer goes back to the MX, and then as you can see in this packet, the offer goes from the MX to PC1, and it has all the same details inside. And then what happens is the client then requests. So the client is now requesting the IP address, and this is going towards the MX. And then what happens is that is then relayed, the request is relayed back to the DHCP server. So all it's doing, it's saying, okay, the client is saying, I am requesting 192.168.101.3, and the DHCP server identifier that I'm sending the request to is 192.168.50.9. Now, then what happens is an acknowledgement happens from the DHCP server. All it is saying, okay, this is now, I've acknowledged that this is your IP address. Sorry, not that one. So it's 192.168.101.3 is your IP address. The relay agent is the MX, is IP, and my identifier, the DHCP server, is 192.168.50.9. So that acknowledgement is sent back to the MX, and then finally in this last packet, that acknowledgement is sent back to the client, and the client has an IP address. So that's essentially the DHCP relay server process gone through. I hope you enjoyed it, and I hope you learned. Thank you.